there, Kathy and Jeff back again. Today we're going to talk about waves.
I got your memo about the topic, and so I grabbed my surfboard. Where's our field trip? California? Hawaii?
Jeff, I think you missed a line in the memo. We're talking about waves in terms of communication today, like radio waves or telephones or even TV. I'm sorry to disappoint you, but no surfing today, unless, of course, you decide to surf the web.
I should have figured a trip to the big waves was too good to be true. So this makes me think about a story I used with some students last year. Kwame's Sound.
Oh yes, that's an engineering elementary storybook. How does that relate to waves?
Well, in the story, Kwame's dad is an acoustical engineer working with a research biologist who uses sound to track the movements of elephants in Ghana.
Yeah.
Kwame gets an idea that he could use sound waves to communicate with his cousin in another village. So he goes about designing a drum and a code for communication.
Well, that's exactly what we're talking about today. How does information, whether it's sound or light, pictures or words, get transmitted from place to place?
For example, in radio, the music or people talking is converted from sound to electronic signals. The electronic signals are converted into a pattern of waves that transmit from the radio station. The radio in your home picks up the waves and converts the coded information back into electronic signals, which travels to the speakers in the radio and is converted back into sound that we recognize as music or speech.
Television is similar to radio, except that the electromagnetic waves carry signals or codes for pictures as well as sound. We now have communication satellites that help transmit information for satellite radio and TV. Satellites orbiting the Earth receive radio, television, and telephone signals and transmit them around the world. They have the capability to receive, decode, and then encode and transmit information.
So let's look at a model for how waves carry information. I have a rope that will represent the wave. If Kathy holds one end of the rope and sends the signal, she's the transmitter. I'll hold the other end of the rope, I'm the receiver.
Okay. If I have a continuous flow of the rope or wave, this would be an analog signal, something like this. It just continues in one long stream wave. An analog signal is used in certain analog electronic devices, or even a human voice traveling through air could be an example of an analog signal. So if the flow of the rope or wave is broken up into pulses, this would be a digital signal. So an example of this would be a pulse and a pause, a pulse and a pause. Of course, that happens very, very quickly. Digital signals are used in computers, CDs, DVDs, and other electronic devices. To make a correlation to the system of zeros and ones used in computers, let's say the simplest digital signal sends one pulse, and that represents a 1 in the computer. And 2 quick pulses would correspond to a 0. In a computer, 1 means the switch is on, and 0 means the switch is off. By sending the on or off signal very quickly, the computer can interpret the code being sent by the transmitter. The on or off patterns are codes for the computer and can be translated back into information.
After using the resources on the Moodle to teach the students about waves, amplitude, frequency, digital, analog, and electromagnetic waves, and how TV and radio work, let them do a little research or learn to read how a computer transmits and receives information. Don't bog down too deep on this. A general understanding of the zeros and ones and what the binary system is all about will be deep enough. We want students to just have a basic awareness of how the computer works.
In any case, all of these communication systems do the same thing. They encode information, transmit the information as waves, receive the information, and then decode the information. So you'll find this as the common series of events. We've seen that in a lot of the MCAS open response questions.
Well, since we can't use my surfboard, let's look for something else that could be really fun and does model the process that Kathy just described. Let's try using Morse code.
So Morse code is a way of communicating with a series of sounds or flashes of light. Just like the computer uses that binary system with 0 or 1, in Morse code, the sound is either a short burst, represented as a dot, or a long burst, represented as a dash.
So I'm going to send a Morse code message, but I could do the same thing with a flashlight and send a light message. Either way, the code is being transmitted by a wave, either sound or light, to the receiver, which is Kathy's eye or ear. She'll be using a Morse code translation chart to interpret my signal. We've uploaded some Morse code information to the Moodle site, so check that out. All right, here goes.
So why don't you just give our viewers a sense of what a dot is going to sound like and what a dash is going to sound
Okay,
like.
so a dot is quick, a dash is longer. Okay, you ready?
I think so.
All right, so it's dot, dot, dot.
When I look at my chart, I see dot, dot, dot is the letter S.
Pause, 1, 2, 3, 4, 5. Dash, dot, dash, dot.
My chart gives me that as a C.
Pause,
Okay,
1,
I got
2,
this, Jeff.
3.
I got this.
Then it goes. Pause, 1, 2, 3.
Could you do that last one again?
Okay.
Tell me what you've got.
I've got a dash,
Yep.
dot, dash, dot,
Okay, got it.
and just a dot.
Okay, Jeff, I think I got your message.
Science matters.